All right, picking up where we left off yesterday, we had our equation for photosynthesis, which was balanced. Okay, someone want to remind me of what our balanced equation looked like, so I can put it up here.
6 CO2 plus 6 H2O yields C6H12O6 plus 6O2.
Okay, and we, as Autumn helped us discover through her analysis of the sentence yesterday, we're going from moles of water to grams of glucose. So our mole ratio will be between water, which is 6, and glucose, which is not there because it is a 1, so the ratio is 6 to 1, okay? And we're going from our known, which is H2O in moles, to our unknown, which is glucose in grams. So this is going to be a two-step process. First, we have to determine moles of glucose, and then we have to determine from there grams of glucose using its molar mass. So, wipe what I have on the screen right now. Okay, so we're starting off. We know we have 3.00 moles of water. And we want to get 2 moles of glucose. Okay, so we're going to take that mole ratio that we found from the balanced equation, which is 6 moles of water to 1 mole of glucose, and we're going to turn it into a conversion factor. Okay, so we know that there are 6 moles of H2O for every 1 mole of glucose. Okay, so this is our conversion factor. Moles of H2O cancel and we'll be left with moles of glucose. So what we're going to do then is do the math. 3 times 1 is 3, and 3 divided by 6 is half, right? So we'll go with 0.5, and that is how many moles of glucose. Okay, so now we have moles of glucose, which is awesome. In order to solve, and because these guys here, so I know there's only 1 sig fig in our conversion factor, but remember that conversion factors are exact numbers, so we exclude them from significant figures, which means we should have the same number of significant figures as our starting product, which has 3, so we should actually have 0.500 moles if we want to maintain the correct number of sig figs for this problem. That's how many moles of glucose we have. Everyone comfortable with me wiping the screen at this point? Okay, so now we have our 0.500 moles of C6H12O6, okay? And we need to convert it into grams of glucose, for which we need the molar mass, which we can determine by taking the molar mass of each element in the compound times the number of atoms of that element in the compound, which, considering we have approximately 24 atoms in this compound, is going to be a little more time consuming than normal. So I will break it down for you on its own separate little slide. So we're going to have carbon, which has a molar mass of 12. Actually, usually 12.01. And there are 6 of them, C6, right? And then H has a molar mass of 1.01, but we have 12 of them. And then oxygen has a molar mass of 16, and we have 6 of them. We wind up with 72.06. Hydrogen comes out to 12.12. And oxygen comes out to 96. So then we're just going to add all of those numbers up, and we wind up with 180.18. Okay, we can use the unrounded version of this in our problem if we want. We just need to keep in mind in the back of our head that we should have 4 sig figs for this particular one. Now, it's possible we'll have, or not possible, we know that the other number in our problem has only 3 significant figures, so our final answer is going to be in 3 significant figures, but just good to remember in case the other number was higher. All right, so we're going to take this lovely number, 180.18, back into our problem. And so we had 0.500 moles of glucose. And we need to take that times our conversion factor. Now we're trying to get 2 grams and change out of moles. So the mole goes on the bottom. We have 1 mole of glucose. I'm not going to write glucose out every time. Just taking too much time. We'll put the molar mass of it above, which is 180.18 grams. So now moles cancel, and we take 180.18 times 0.5, and we wind up with 90.09 grams, but we need to round that to 3 significant figures. So we'll look here, and we'll wind up with 90.1 grams of glucose. So if we started with 3 moles of water, this is how many grams of glucose we could expect to produce. Okay. Now, taking that same equation that we just worked with, I want you to tell me what is the mass of carbon dioxide in grams that you would need in order to react with 3 moles of water. So it's the same type of problem, the same setup. We're just, instead of going to grams of glucose, we're going to grams of carbon dioxide. So look back at your balanced equation, get your mole ratio, make your conversion factor, and then convert to grams using the molar mass of carbon dioxide this time. Okay, so we're going to start with the balanced equation. The ratio between carbon dioxide and water, which are both on the products side of the reaction, because remember I said sometimes you'll have one reactant and 1 product, sometimes you'll have 2 reactants, sometimes you'll have 2 products. It can cross the line, or they can both be on the same side. This time we had 2 reactants, carbon dioxide and water, and they both show up as 6 moles. So the ratio would be 6 to 6, which you may have noticed can be reduced to 1 to 1. Okay, so we could very easily just skip the first step of this process and just say, well, if it's 1 to 1, if we have 3 moles of water, then we'll have 3 moles of CO2, and you'd be absolutely right. And if your brain can function on that, then feel free to skip this step. But if you're a person who needs to see processes, you can still write it out and say 3 moles of water times 1 mole of CO2 over 1 mole of H2O, so that your moles of H2O cancel, and you wind up with 3 times 1, which is 3 moles of CO2. Okay, so you can go through this process if it helps you to see the process, or whenever you have a 1-to-1 ratio, you can just know that you'd have the same number of moles. So now that we know that we have 3 moles of CO2, we need to convert to grams of CO2. But in order to do that, we need the molar mass for CO2. So we know for carbon, it's 12.01 And then for oxygen, it's 16, but we have 2 of them, so it'll be 32. And when we add those up, we get 42.0, or no, 44, not 42. 0.01 grams per mole as our molar mass. So now we can take that back up here and say if we have 44.01 grams of CO2 for every 1 mole of CO2 that we have. So then moles of CO2 cancel. And we are left with whatever 3 times 44.01 is, which comes out to 132.03. And that would be grams. And then that's just our answer. We can round it to 3 significant figures because this is a multiplication problem and our smallest number of significant figures is 3, so we get 132 grams of CO2. There we are. Okay. Now with that type of problem under our belt, it's time to move on to a new type. Don't worry, this one is similar. This is the reverse of what we just did. So still just 2-step problem, but we're gonna go from grams to moles instead. So for this one, you're converting a mass of a given substance that they've given you in grams to an unknown substance in moles. Same 2 conversion factors are required. You need the molar mass, this time of the given substance, instead of the unknown, because you're going to go from the given substance to moles, and then you'll still need the mole ratio from the equation. So process would look like this. You'd have the mass of the given substance in grams. You would take that times the molar mass of your given substance, which you can get from the periodic table. And then once you have your moles of a substance, you'll take it times the molar ratio conversion factor you've made from the balanced equation to get moles of your unknown substance. So like I said, this is just the reverse of what we have been doing in the last problem. Oh, I should give you a second to write. Since the bell's gonna ring on us, let's have your homework be to do example problem 4. Okay? You'll notice that you have a equation, but that it's not balanced. So you need to balance the equation before you start answering questions. There's question A and question B. Okay? So they have given you a starting mass in the problem of a substance. You'll balance the equation to get your ratio. Then you'll find moles of NO, and then when you go to the next one, you'll find moles of H2O. Sound good?